Hello and welcome. Thanks for joining me for part 2 of solving basic equations. Now, last time we were using some inverse operations to undo all the other numbers that were around our x and arrive at the mystery number for what x was. It was surprising because often we got two solutions, and that's what's going to happen a lot in this video. Now, it's important to understand that you won't always undo the same operation first. And this is where it depends on, as I was mentioning before, the structure of each equation. But in generalness of your solving technique, you're going to be working with what's furthest away from the x and zeroing in on it. Now, typically, the squared tends to be the closest thing, the closest operation to the x, but that is not always the case. You can see over here in this example, we actually have a plus 3, which is much closer. It's in a much more intimate relationship with the x than the squared is right here. So in this video, I'm going to open your minds up to the possibility of decision making. Which operation should we seek to undo first, and how is the problem going to follow after that? And long story short, the answer is going to be, let's work from the outside in. Now, with most generalities, there's going to be exceptions to those rules, but those are exciting opportunities to gain a deeper understanding. So let's take this at face value for right now and sort of go with it and explore and see what else that we can figure out. So first, let's start off with one of our more familiar problems, like with b. What we've done in the past is we've subtracted 3 from both sides, got the x squared by itself, and used the square root as an inverse operation to eliminate the squared. We remember that we have both plus and minus 7. In other words, both positive and negative 7 will multiply by themselves and create a positive 49. What's really cool here is the idea that when we've square rooted one side of our equation, we've kind of come up with this duality, this double solution. And that's still going to happen here in the unfamiliar situation, where we have this squared, but it is much further away from the x. So it's kind of calling out to us saying, hey, let's get to know x a little bit better, but first, let's get rid of this squared first. And what that does is it leaves us just with the x plus 3, but on the other side of the equation, it actually gives us the familiar plus or minus 4. Now, this is a little different because typically in the problems we've done before, we stopped when we got to the plus minus. But that's not always the case with problems right here. You have to continue because we still have not figured out a definitive answer for what x could be. Because remember, it could be more than one number. Now in class, I gave you guys two options where I said, to deal with this plus minus, there's two basic ways you can approach it. You can split it up into two situations, or you can keep it. Now for the sake of brevity, i.e. keeping this video short, I kind of want to discourage you from keeping the plus minus. Not that you shouldn't, not that you can't, but I believe overall your work organizationally will be better if you split with the plus minus, and it'll also help you understand future concepts like breaking apart the absolute value and just case analysis, proof by exhaustion in the future. I think splitting up a problem into subproblems is a great technique to build upon, and this is the one that I'm going to emphasize today. So let's restart this problem over again. We notice that the furthest operation from x is our x squared, and in addition, we need to start undoing our operations. So if I square root both sides, my squared will go away. I'm left with x plus 3. And on the other side of the equation, I have my plus or minus 5. Now what that's signifying is there's actually too many equations here. The x plus 3, it could be equal to a positive 5, or at the same time, the x plus 3 could be equal to a negative 5. And this preserves the idea that there are going to be two solutions to this problem. In either case, you would subtract 3 from both sides, and it will produce different answers. X could equal 2, or X could equal -8. And down here in this box, I told us to look at both answers. Because often we can get trapped in habits where we run through a bunch of problems and we say, oh, the answer is ±4, the answer is ±7, and we tend to fall into a habit of laziness where we assume that it's going to be the same number every time, and there's going to be a positive version of it, and there's going to be a negative version of it. But right here, we're noticing that this is an occurrence where we have a +2 and a -8. Not a ±2 and a ±8, but actually two distinct numbers that are different distances away from 0. So I'm going to caution you not to ever rush through any of these questions and just assume it's, oh, plus or minus this, plus or minus that. You have to understand the structure of the problem, and that's going to give you hints about what the future answer is going to be. Now, we're going to practice a few more of these situations, and before I go over these, I want you guys to compare and contrast them. Look for the new structure, look for the old structure, and make a prediction about what it is you would like to undo first in the equation. I'm taking this seriously. I actually want you guys to pause the video, stop it, try these out before you watch me do it. Bum, bum, bum. Okay, so now we're ready to go over these. And I'm just going to remind you again, if you're just watching me do these over and over again without trying, it's just like watching me run 4 miles. I'm going to get in better shape, but if you're not putting in the effort, you know, it's not really going to do anything for you on your end of it. We need to try out some work and receive feedback on it so that we can understand how to reason through problems better. Now, here, this reminds me of a problem that we worked on before, where there aren't these large parentheses that are kind of preventing us from getting close to x. So I'm going to add 7 to both sides first. 3x squared is equal to 27. I see I have a times 3 in front, so let's divide by 3. If x squared is equal to 9, I just need to take the square root of both sides, letting me know that x should be equal to a positive or a -3. Now you will notice that we tend to get the same numbers over and over again, and that's really just because I want to choose whole numbers. It's not that we can't have decimals or that we can't have fractions, but to just not introduce other areas of conflict into the problem, I'm tending to keep these solutions as whole numbers. But that's not to say we can't get a plus or minus 2.5 or maybe a 4.7 and a 5.1. You know, these are all legal things that could happen in the problem. But on to F. Now in F, I'm looking at it and I see, oh, we have those big parentheses again. And the x squared is the furthest away, it's on the outside. So let's go ahead and square root both sides first, giving me a positive and -6 simultaneously. And now, knowing what we just learned, I'm going to break up this situation into both positive and -6. Solving them both by adding 4 to both sides, I'm going to arrive at two different solutions. At first, I'll get x equals 10, and then later, I'll get x equals -2. Let's go down, let's go down. And here in the notes, I stepped it up a level where I wanted you guys to take some time to intuitively think through the problems. And these are actually unlike anything that we've seen before. I've combined actually both types of problems into one, where we have these giant parentheses again to undo, but it's not actually what we want to undo first. We have this little +4 appended onto our problem, just like in the previous problem, this -7 was kind of just tacked onto it. So we're going to want to undo that first. So by subtracting 4 from both sides, you'll notice that we land again in familiar territory. It looks a little bit like here when we had our big parentheses and the squared equal to. This is a hint that I can square root both sides, giving me x plus 1 equal to both positive and -8, which means I should say it's equal to both positive and -8 at the same time. Oh, take away 1, looks like my pen slipped there, giving us that x could be 7 in one situation, or x could be -9 in the other situation, and those are both solvable. Now H, I like this one a lot. This tends to be a pretty thematic issue in Algebra 1 about should we be dividing first or should we be square rooting. And I'm going to ask you to think again about, what it is that we're undoing. And, just try it out. If you try out one method and it's not working for you, go back, try it the other way and see if by plugging it back in that actually arrives at the answer. But just like we tend to do, or I should say undo, plus and minus first, the next thing we would naturally like to undo is multiply and divide. So I could divide both sides by 5, again landing me in familiar territory. Notice how now it's just like G, which was just like F, by taking that 5 and dividing it on both sides. Now if I'd square root it, you should notice that again the numbers are repeating. We get plus or minus 6, which breaks it into the two situations. It could be the positive 6 or it could be the negative 6, but either way, in both instances I should add 3 to both sides, giving me that x would be 9, or if I add 3 to this one, we'll get separately that x would have been minus 3. So there you have it. We've looked at some new situations and we've related it, in fact transformed it back into the old situations, and that's a great algebra skill to start, let's go with developing, and a great thing to start looking for in your future problems. Now down here I did give us a challenge problem. There is actually a typo in it. I forget if maybe this 11 was supposed to be a 10 or the 6 was supposed to be something else. But it is solvable, but it will not give you a whole number solution. So I apologize for that. It looked kind of silly when I wanted to do it earlier, but hey, everyone's human. Stay tuned for the next video. Let's see.